Okay. All right, we are going to look at a model of an enzyme today. You've got several components in your Ziploc bag, so take them out and lay them on the table just like I have them here. You've got an enzyme. An enzyme, of course, is a protein that has a special shape, and in this case it's shaped like the letter C. There is a little opening here. Be careful with that. That's supposed to be there. This is known as the active site of the enzyme, and so where the reaction takes place is going to be right there inside this shape. This one here, they go together, the two halves, and it's meant to show you what a double sugar looks like. In this case, lactose, and the name of the enzyme is lactase. And so the enzyme will always be named after what it's working on, which is called a substrate. So lactase ends in ASE, and almost every enzyme you come across is going to end in ASE with just a few exceptions. If you remember from the DMD video, there was an enzyme called protease that ended in ASE. So that enzyme is triggered by the calcium and causes more of the breakdown of the proteins in the DMD patients. So we're still learning about enzymes here. So what happens? The enzyme that opens up and the substrate fits inside. So lactase surrounds lactose. This causes a reaction to take place that would not have happened as easily on its own. And the substrate breaks apart into the two components, glucose and galactose. So this enzyme now can keep working on another bit of lactose, and again, and it can continue working on as many lactoses that are out there. So enzymes are very specific to what they work on. You notice what a perfect fit this one is when it goes inside. That's called the enzyme substrate complex. Now, there are other things that enzymes work on. This might be another substrate, but notice it's not a perfect fit. It's got a lot of gaps around it. So this substrate will not react inside of this enzyme. So it's just there to show you that the enzymes have to fit their substrates. So what does your body do when it wants the reaction to stop? Well, there are two things. There's a competitive inhibitor and a non-competitive inhibitor. The competitive inhibitor goes in, it fits into the substrate, but it's inert. It doesn't do anything. It's a single compound. It's not going to break apart. So then you get the lactose trying to get in, and it can't because this one is out competing for the spot. So the reaction would stop. Another way that the body can do it is to take a competitive inhibitor. A competitive inhibitor is a little piece of a compound, small bit of amino acids. It changes the whole shape of the overall protein, the enzyme, and so now, again, the lactose can't fit in. So why are we talking about lactose and lactase? Well, most people have a lot of lactase in their body when they're little, okay, because what do babies drink? Milk. Milk contains a lot of lactose. So lactase helps to break down the lactose that the babies are drinking. The majority of us, like 85%, no longer make lactase past about the age of 4, but it doesn't bother us. Lactose goes through our bodies and we don't seem to notice any difference. But for those few that this double sugar causes difficulties, might give them stomach aches, gas, things like that, we call that lactose intolerant.